Hello and welcome to Mr. Connally's Math. We got lesson 2.2.3 today, problems 246 through 50. Don't forget to give this video a big thumbs up and subscribe to get information about future videos. Notebook setup, we know the homework is in the bottom right hand corner of our notebook. We always want to title it homework, write the number of the problems in the focus note margins, show our work, box our answer, and write in a complete sentence, and use the back of the paper if you need more room. When watching this video, here are the guidelines. Watch and listen to this video. Sound should be on. Do not skip ahead. Do not just mindlessly copy the work. Pause the video when you need time to write or think. Put a question mark next to problems that you don't understand. Rewatch the video when needed over and over and over again if you need to. Ask questions in class or in the comments below. Question 46. Find the area of the perimeter of the figure at right. All angles are right angles. Show all of your work. Okay, so now we've moved beyond just the graphing. We've got a real life shape. This could be a shape of a building. It could be a grass area. It could be a backyard, anything like that, although 10 centimeters would be a pretty small backyard. So when we're doing this one, we want to find the perimeter first. Remember, perimeter is exactly like toothpicks. So if this side says there's 10 centimeters, imagine if there was 10 toothpicks all the way across. Okay, so when we're building our area, we have to, or the perimeter, we got to make sure that we add up all the toothpicks. So this side would be 10. So the perimeter is going to have 10 in it. And then we're just going to keep adding toothpicks along the side. This side has 10 toothpicks across it, so we'll add another 10. And then we keep going like that. There's 5 on this side. I like to draw along the outside of it so that way I know I've covered all my sides. And then here's another 4 toothpicks across this way. Okay, so you get the idea. We're just adding up all the sides. Go ahead and do that on your paper. Pause the video. When you're done, let's go into area. Okay, once you get your answer, you'll add up all those numbers together and you'll put it in right up here. Okay, so area. Area is a little different. Area is how many squares fit across inside the circle, or inside the shape. So this is 10 centimeters on this side. That means, imagine next to those toothpicks you cut across, you use tiles all the way through, and you're imagining how many of these tiles would fit inside of it. Okay, so by the way, on the back side, this is 3 and this is 4. So from here to here, it's 3 plus 4 is 7. And so that would make this another 3, because 3 plus 3 plus 4 equals 10. So that means this is 3 as well. Okay, so now we're trying to figure out how many squares fit inside here. One of the best ways to do that is to break it up into smaller rectangles. So for instance, you might do this rectangle right here. This rectangle is 3 by 10. So the area is going to be 3 times 10. And then we need to add that to the other areas. Now this is, again, not a good shape, a real shape. This is 2 shapes put together, so it looks like we have a little rectangle or square inside here and then another one inside here. We know this one on the right is going to be 5 times 4. And then we'll add that also to the area of this one right here. It's going to be 3 times something. So once you figure out what that is, through the process of elimination and indirect measurement, you'll add that right here, and then multiply all those products, and then add them all together, and you'll get your answer of the area, which we know is in centimeters square. Centimeters, which we learned in the last lesson, is centimeters square. So put that answer in there, and then this answer up here will be in centimeters as well. Okay. Make sure you complete that. 247. Draw and label two different rectangles, each with perimeters of 20 units. Do the rectangles have the same area? Explain your thinking. Alright, so perimeters of... Oh, this one asks us, you can use the E tool. I love the E tool. So each of the perimeter of 20. So that's 20 toothpicks. So let's go to the E tool. Okay. And it's got to have 20 toothpicks. So we'd add up all the toothpicks together. There's 5, or 4, 5. Let's do the same thing on the other side. 5. Okay, so that's 5 and 5, that's 10. If I were to put some on the top, remember to double tap to put it sideways. Okay, so 5 plus 5 is 10, plus 1, 2, 3, 4. That would be 14. Okay, so I need it to be a little bit bigger. So if I'm at 14, then I need to add, there's 6, there's 2 more, and 6 is 12, plus 2 and 2 is 4, so that makes 12, 13, 14, 15, 16. And we'll still need some more to do that. So you can just keep doing it like that, adding your own toothpicks, seeing how you can, just adding a couple more. Now we're up to 18. So it looks like we're going to have to do 1, 2, 3, 4, 5, 6, 7, 8 on each side. There. 8 plus 8 plus 4 is 20. So this rectangle is 2 by 8. And that gives us a perimeter of 20. And now you can just rearrange it. So on your paper, you can just draw first rectangle. It's 2 by 8. And so that has a perimeter of 2 plus 2 plus 8 plus 8. And you add up all together and you get 20 units. Alright, and then the area, you'll compute the area of this one. I'll give you a hint. It's length times width, so it would be 8 times 2. And you'll put that answer right in here, 16 centimeters, or 16 units squared. Alright, now it says we're supposed to draw 2 different ones. So now we'll draw another one. That's easy. We can just use the other one we were doing. This one right here, and then we can just take them and rearrange them. Let's scoot it over a little bit, and maybe scoot it over a little more. Now we can take some of those, turn them sideways. You get the idea. You could do something like that. Still doesn't fit, so we might have to scoot those over a little bit. Oh, that worked. Alright, so this one is 4, and there's 1, 2, 3, 4, 5, 6. 6 by 4 would give us a perimeter of 20 as well. So all I had to do is rearrange them. Okay, so that one we just did, why don't you go ahead and put the numbers here and here. Okay, and find the perimeter of that one. And also the area is gonna, we said 6 by 6, sorry, 6 and 4. So 6 plus 6 would be 12, and 4 plus 4 is 8. That would give us 20 units, but then also the area would be 6 by 4 is 24, so you'll put 24 in here, units squared. And we look back and we see that the units are not the same. This one had 16 units squared, and this one has 24. So because of that, they do not have the same area. And so you would say they do not have the same area, and then explain because, and go ahead and explain it in your sentence right there. All right, have those in your notes. When you're done, pause it and now finish the problem and then go on to the next one. Okay, I'm assuming you've already paused it and finished the last question. Now we're on to 248. Think about the base 10 blocks used during the lesson. Using 100 block, a 310 block, and 6 1 blocks, create a shape with the largest possible perimeter. Alright, so this one you'll have to play around with the E tool. It'll help. Here's all those shapes right there. Okay, and now our goal is to make the biggest perimeter we can. So you just start playing around with it, seeing where you can get a shape with a big perimeter. Doing something like that. Okay, and then count all of them. You would count the sides, the perimeter. This would be 10, 11, 12 on this side, etc. Could also just start adding like this. You know, keep playing with it. See what gives you the biggest perimeter. Remember, we're not counting the squares. The squares will be the same. The area will be the same no matter where we put these things. And also, they have to touch the side like this. You can't put them on a corner like that. It's got to be on the side. That would work. This would not. This would not. It all has to be connected like that. Okay, then you go like this. Add some more perimeter here. Okay, so add up the perimeter of all those and see what you get. When you're done, move on to the next question. Okay, so whatever drawing you have, you figured out, go ahead and draw it in there and say what the perimeter is for this question. So draw your answer here. All right, 249. Given the data in the table below, copy and complete the histogram to represent families of various sizes. Remember that data falling on a tick mark, 3, 6, 9, etc., goes in the bin to the right of that mark. What range do most families fall between? Do you see any families that are much larger or much smaller than other families? Okay, so the keys to this one are, we need to complete the histogram. Remembering the data goes in the bin to the right of the mark. And we're looking at what range do most families fall between. And are any that are much larger and much smaller. Alright, so let's start by getting this together. I'll get you started and then you can use the sentence frames down here to answer the questions. So the Latrice family has 4 family members. So that would be right in here between 3 and 4. So we know that would be about this high for that. The James family is 8, so that's between 6 and 9. The Fu family is 7, so they would also go in this one right here, so that means we would raise it up to the 2. And technically, you don't use the boxes, you just draw a bar graph. But we're not done, so we'll just have to keep adding. And then the Byron family has 3. Now that would go to the right, so that means they would also be caught up right there. So we can erase that part. Okay, so you're starting to get the idea. The Evan family has 2, so that would go here. Just keep adding to the bars until you're all done with all of these other families. And then answer the question. You got to look at the data and see where everything goes. I'm going to go ahead and finish this. Diamond has 11, so that's between 9 and 12, so that would go right here. Then there's 5 and 5. That goes between 3 and 6. So that means that would go all the way up to here. And the Sheena family has 6. That would go one more up here. And the Ryan family has 8, which would go right here. Okay, so now you just analyze the trends of the data. And we see that it looks something like this. We'll say most families fall between which numbers? Well, if we look on the graph, there's actually 2 that tied. They both had 4, which was this bin, 3 to 6, and then 6 to 9. So this is technically 3 to 5, and this is 6 to 8. So between 3 and 8. So you would put that answer here. Most families fall between 3 and 8 members. Okay, and now is there a family that's much larger or much smaller than the others? So go ahead and look at this data and decide, is there one that's much larger, or is there one that's much smaller, or maybe both? Go ahead and answer that right in here. Pause the video. When you're done, move on to the next question. 250. Consider the units in this list: inches, centimeters, feet, yards, meters, kilometers, and miles. For each situation given below, list the units that would be most commonly used to measure the length or distance described. Okay, so they're all highlighted for your convenience. So inches and centimeters, those are both yellow because they both measure short distances. And then feet, yards and meters. Yards and meters are kind of a medium distance. Feet is kind of in between short and medium. And then kilometers and miles definitely represent long distances. All right, so let's think. Distance from Bellingham, Washington to Washington, D.C. Okay, so that's from the west coast to the east coast. That's a pretty long ways. We're probably going to use the largest measurements, so we could use kilometers or miles, but since these are both in the United States, we're going to use the one used most common in the United States. So put that answer right in here. It's either kilometers or miles, you decide. B, length of a small stuffed animal. The length of a small stuffed animal. Okay, so it said small. Okay, so we're probably using one of the short ones, so we could use inches or centimeters. And then feet is something in between. When we use feet for a stuffed animal, it might be a foot or more, so maybe we still want to just keep it with inches. So inches or centimeters, again, it's the United States, so we're probably going to use inches. How far you walk during lunchtime at school. Now picture the quad area at school. Do we have a huge quad area? Not too much. Even if you walked out to the blacktop, you probably wouldn't go a long distance like miles. So something in between, probably not feet. A foot is about almost as big as most of your feet. So you probably take more than quite a few steps around the whole thing. Yards is 3 feet, so Maybe yards would be a better one, or meters. You decide which one. Again, we're in the United States, so which one would you use? And then finally, the height of our classroom. It's probably not the long distances. It's probably not the short distance. It's one of the medium ones. So you decide what would go there. All right, you did a great job. I hope that you watched this as you were supposed to, and you got some new information to add into your memory banks. And all I have left to say...
Congratulations on completing your homework assignment. If you like this video, be sure to give it a big thumbs up and subscribe to Mr. Connally's Math to get updates on future videos. Thanks for watching.